In the last class, we have discussed about the reaction of aldol condensation, where the basic requirement is the alpha hydrogen. But one question arises: what if there is no alpha hydrogen or alpha carbon in a compound or in an aldehyde? Then what happens if it undergoes oxidation or reduction? Here you see we have to take the formaldehyde compound where there is no alpha hydrogen or alpha carbon. In case you have forgotten what is alpha, the term alpha in a compound, let me remind you once more. This is the functional group, the portion that is given in pink color. This is what aldehyde group, CHO, right? So the carbon that is attached with this functional group, so this is a functional group. There should be one carbon in place of this hydrogen. Suppose one carbon, that carbon which is attached with this functional group is known as the alpha carbon, right? And there has to be attached hydrogen as well, so those hydrogen are known as the alpha hydrogen. The hydrogen that are attached with the alpha carbon are known as the alpha hydrogen, and the carbon that is attached directly with the functional group compound is known as the alpha carbon. Here you see there is no alpha hydrogen or alpha carbon as well, so they will itself undergo oxidation and reduction, right? We have to take two compounds of the same compound. We have to take two molecules of the same compound. One molecule will be converted to alcohol and another one will be converted to the salt. Now what type of salt it will form? It depends on the reagent. If we are taking potassium hydroxide, it will form potassium carboxylic salt. If we are taking sodium hydroxide, it will form the sodium salt, right? But you have to remember, we have to take concentrated alkali. These two are alkalis, you know, bases. So let us read once here. Aldehydes which do not have alpha hydrogen atom undergo self-oxidation and reduction heating on heating with concentrated alkali. So one molecule will form alcohol and another will form the carboxylic acid salt. Now let us see the reaction here. So two molecules of formaldehyde is taken and concentrated potassium hydroxide is taken and then heated. So this compound will be converted to alcohol. This thing you remember overall, and this compound will be converted to the potassium salt. Here what is happening here, you see, in place of oxygen, this C double bond O, OH will be attached. Because we are changing the functional group, then only we can say that we are changing the compound. Okay, always remember, when we are talking about the chemical properties or chemical reactions of a certain type of compounds, like for example we are talking here about the aldehydes, the reaction will always take place at the functional group part. Okay, the other alkyl or aryl parts remain unchanged, only the functional group is changed. Therefore in most of the reactions in the book, only the generalized equation is given, generalized formula is given, like RCHO, because the reaction does not depend on R will remain as R only. Okay, only the functional group will change. Similarly, it is designated as RCOOH. It means what? Only the COOH part is important here. We are going to change only that part of the reaction, right? That part of the compound, sorry. So only that is written. So the alkyl or the aryl part is remain intact. Now you see here the reaction is taking place only at the CHO. Okay, so COH here, in place of oxygen we will write OH because this is the alcohol part. Then hydrogen and hydrogen which is already there in the compound, and one hydrogen has come from the this KOH. Okay, now here again you see here C double bond O is remain intact from here, right? Now what is happening here, in place of one hydrogen it is replaced by OK. Clear? And this hydrogen is remain intact. So you have to remember, here one alcohol is formed, OH is formed, and here one potassium formate you can say that is formed. Okay, potassium salt you can say in general. The other things you can write it yourself. Just remember how to write the reaction. You know it is an alcohol, so obviously it will form COH. Fill up other parts with hydrogen, right? And this is what? An acid salt, an acidic salt. So you know the formula for carboxylic acid, it is C double bond O single bond OH. Now it is a potassium salt, so in place of hydrogen one potassium will come. Next you count how many atoms are left to fill up, then you fill up with hydrogen because there is no other any other carbon here, right? So this is how you remember the reaction, otherwise it's becoming very complicated when we are setting so many reactions together. If you have understood this is very easy because this is the aryl portion which will remain intact. Obviously our center of focus is the CHO. Okay, so two molecules of the similar compound is taken, that is your benzaldehyde plus sodium hydroxide. Now the reagent is changed to sodium hydroxide in place of potassium hydroxide. Okay, here also what will happen, alcohol will form. So in place of CHO what you will write? Obviously with carbon one OH will be attached, right? One OH will be attached. Next, how many atoms are left to fill up? Two atoms, because one bond is already with this carbon, right? Aryl chain. Next we have taken one OH, so two chains are formed. Next what is left? One hydrogen, second hydrogen, so it is CH2OH. So this way it becomes easy for us. Next you have to remember we are forming the acid. Okay, next what you will write? In place of CHO you will write what? One carbon, obviously it will be there, right? Then C double bond O single bond OH, but you know it is a sodium salt, so in place of OH you will have to put O and A, like here. Next you count if there is any other atoms left. There is no atoms left because one bond, then here double bond and here single bond. So 1 2 3 4. So there is no need of putting any hydrogen here. Clear? This is a name reaction, that is the Cannizzaro reaction that we have studied just now. You have to remember aldol condensation, Cannizzaro reaction, Williamson reactions. All these important reactions, they usually give a short notes or they will give the reactant. You have to recognize the reaction, what type of reaction is this, from the reagents as well as from mainly from the reagents only used to determine what type of reaction it will undergo. So you have to learn it so much that you remember the reactions, you by heart it by practicing. Okay, also remember the products, what type of products will form. Okay, then it is easier. The next step is to write the structures. The next reaction is electrophilic substitution reaction. Aromatic aldehydes and ketones undergo electrophilic substitution at a ring in which the carbonyl group acts as a deactivating and meta-directing groups. So the substituent that is attached with a compound determines the incoming group will attach in which part. So this group, the CHO, the carbonyl group, is a meta-directing group, means whatever incoming groups it is there, it will direct where it has to bind. So this is a meta-directing group, and since here you see nitric acid and sulfuric acid is taking here, obviously we are talking about the nitration. And in nitration what happened, what group is added to the compound, that is your NO2. Since it is a meta-directing group, it will direct the NO2 group to attach in the meta position. So this is the meta position with respect to this substituent. Okay, ortho, this is meta and this is para. So it is, the name is meta nitrobenzaldehyde. Okay, this is also an important reaction. You have to remember where to put the NO2 group and also what reagent is being used here, and also that the carbonyl compound is a meta-directing group. Next, we will discuss about the methods of preparation of carboxylic acid. So it is basically done from alcohols, from primary alcohols and aldehydes. Okay, you see here what I have told in the previous part is that usually they will give you the generalized formula of a compound, because this R is not the portion where reaction is going to take place, so no need to bother about the R. It can be as long the R can be long as well as short. Okay, the chain can be like 2 carbon is there or 3 carbon is there, it does not depend on that. The total reaction, the whole reaction is dependent on the functional group of a compound. So this is what CH2OH. This is the alcohol part, and in this portion only the reaction is going to occur. So it is given in pink color. Other part is not written because it is not required here. Okay, so since we are talking about the preparation of carboxylic acid, it can be prepared from alcohols using alkaline KMnO4 and acid. Okay, acid is means designated as H3O positive here. So this CH2OH, one carbon is there. That also is important to remember if you want to learn by heart. Okay, so one carbon is there. Okay, you have to put one carbon here. Then in place of H2OH, you know what is the formula for carboxylic acid? It is C double bond O single bond OH. So this is how you have to remember the reaction. Now if one reaction is given to you, 1 decanol, you know that the alkyl part is not required here, right? The alkyl part is not required here. What is required? The CH2OH, the alcohol portion is required. Now here what is being used? This is chromate plus sulfuric acid, and this reagent is known as the Jones reagent. What is being changed? The pink color portion, which is the alcohol portion, that is being changed into C double bond OH, and this is the decanoic acid. Okay, sorry, I said this is C double bond OH. It is C double bond OH, decanoic acid. The next reaction takes place from alkyl benzene here. So this is the alkyl and this is the benzene. Together we can say alkyl benzene, right? So the alkyl chain, it can be consist of any number of carbon. So alkyl benzene plus this is KMnO4, this is KOH. You can say alkaline KMnO4 potassium permanganate, and heat it. What you will get? C double bond OK. And then it is acidified intensively, you will get the benzoic acid. So let us read here once. Aromatic carboxylic acids can be prepared. So you see, we are talking about the preparation of aromatic carboxylic acid. We have not yet discussed about the aromatic. We have just talked about the alkyl carboxylic acids. Okay, now we will talk about the aryl carboxylic acids. By vigorous oxidation of alkyl benzenes with chromic acid or acidic or alkaline potassium permanganate, the entire side chain is oxidized to the carboxyl group permanganate. Irrespective of the length of the side chain. You see, this is short alkyl chain, this is the lengthy alkyl chain. Here 3 carbon is being used. So is the entire side chain is oxidized to the carboxylic group irrespective of the length of the side chain. So this side chain does not matter at all. This whole group will be removed and it will be replaced with the carboxylic acid. Okay, so this is how it is prepared. Here also you see the same procedure is being followed. Okay, so whether you take this or this, it will form benzoic acid only. So this thing you have to remember, whether it is a short chain or it is a long chain, whatever it is, it will only give one product. The same product you will get, benzoic acid. Okay, next is from nitriles and amides, RCN. Now this CN is the center of reaction. Okay, so this is being converted to C double bond O and H2. So this is what? Amide, and this is being converted to the carboxylic acid. Here we will take directly amide, C double bond O NH2. Okay, ethanamide, and it is being converted into ethanoic acid plus NH3. So even if you don't write the byproduct, it's okay, but this is important here. Here also amide is converted into benzoic acid. C double bond O NH2 is converted into C double bond O OH plus NH3. Means what? If you take nitrile, from nitrile you can produce the amide, and from amide you will get the carboxylic acid. So in the next 2 examples, the nitrile is not shown here, directly the amides are shown. So carboxylic acids can be prepared from the amide as well. The next reaction is from the Grignard reagents. So this is the Grignard reagent, the generalized Grignard reagent. This is the alkyl chain. If we say it is CH3, you can say CH3MgBr. Okay. So this compound is reacting with carbon dioxide, or you can say it is given here dry ice. Next, C double bond O, then COMgX. This R will attach with carbon and the rest MgX will attach with oxygen. So it will form what? This double bond will split into two. One it will form with R and another one what will form OMgX. Okay. Now H3O positive. It means it is acidified. You will get R C double bond O H, double bond O OH. Okay, and R is remain intact, and this MgX is replaced by H here, and nothing is changed. First of all, the double bond O will remain same. One double bond O will break down into two single bond. Okay, one it will attach with R, that is your alkyl chain, and another one with the O, and it will form OMgX. Now from this MgX, this MgX can be replaced by hydrogen, so you will get R C double bond O OH. So this is the respective carboxylic acid. Carboxylic acids can be prepared from acyl halides as well. So this RCOCl, this COCl is given is the acyl halide. Now this acyl halide is hydrolyzed with water to give the carboxylic acid. So if you have learned by now how to convert a compound into another compound, it will become very easy. If I am saying an acyl halide is being converted to carboxylic acid using water, or it is being hydrolyzed, you can directly write that in place of COCl we will put the C double bond OOH, because we are converting to carboxylic acid, right? So this is how it becomes easier. Again, another method is there that carboxylic acids can be prepared from the benzoic anhydride. So this in between this carbon and because here 2 is given, no, so two parts of this compound will be there. This whole compound, two parts of C6H5C double bond O will be there, and one in between oxygen will be there. Let me show you by writing. Okay, it is just wait a second, let me write. Okay, so this is how an anhydride is written. C6H5C double bond O, in between these two carbon, one oxygen will be there, and again this portion is repeated. So this is anhydride, sorry. This is benzoic anhydride. Why it is benzoic anhydride? Because benzene is being used here, now C6H5 is used. Okay, so water. Now which portion will undergo oxidation? Obviously you see here, this is the anhydride portion, right? And this is first, this is second. So C6H5 COOH, from here also you will get C6H5 COOH, because this is the portion of the functional group. Here it will change another carbon also we have with the functional group attached, so from here also it will change. So you will get two molecules of the benzoic acid. Let us take benzoic ethanoic acid. Here you will get benzoic acid and here ethanoic acid. Clear? How this is written? Let me show. Okay, so this is the benzoic ethanoic anhydride. Now you know that the breaking will take place here, right? So from here what you will get? CH3COOH, and here what you will get? C6H5C double bond OH, right? So here you will get benzoic acid and here you will get the ethanoic acid. The two portions in between the oxygens is being broken here, that is it. Okay, this is the reaction. Now the preparation of carboxylic acid from ester can be done using the same cyclogy about anhydride. Okay, the same mechanism is followed, but the difference is that both the parts are being converted into acid, but here one part is converted to alcohol and another one is the major compound, that is the benzoic acid. Other one, the alcoholic part, will be the byproduct or the minor product. So from here you see we will take the ethyl benzoate. So two parts are here. This is the benzene you say, and this is the ethyl group, right? So our purpose is to convert this compound into a aromatic acid. We will hydrolyze it or we will treat with acid. Next we will get the benzoic acid and this is converted to alcohol as we said. So this is the ethanol. Next this is ethyl butanoate. So this is the 1 2 3 is there. So this is what the carbon having the long. First of all you have to be very clear which one you have to convert into acid and which one to convert into alcohol. Okay, so this is the portion, this is the ester portion. Now one part to your left and another one to the right. So you see the left hand portion is having longer chain of carbon, so this is to be converted into acid and the shorter chain is converted into alcohol. So you will get CH3 CH2 CH2 C double bond OH, right, and C2H5 OH. So here also ethanol is the byproduct and this is the butanoic acid.